Hi, my name is Aron Meltzner, and I'm an assistant professor at the Earth Observatory of Singapore at Nanyang Technological University. My research interests lie at the nexus between sea level research and active tectonics. Last week, there was a powerful earthquake off the coast of Alaska with a magnitude of 7.8. It occurred along a subduction zone where the Pacific plate is subducting underneath the North American plate. The shaking results from the motion between the two plates. That motion between the plates also lifts up the seafloor, which then lifts up the water above it, and that's what causes a tsunami. Now, the earthquake last week at a magnitude of 7.8 was moderate. In 1964, there was a magnitude 9.2 earthquake that was much bigger and produced a much bigger tsunami that went across the Pacific Ocean and devastated communities across the basin. In Southeast Asia, we've had large tsunamis in 2004 in the Indian Ocean and in 2011 off the coast of Japan. My work is at the nexus between sea level research and active tectonics. Now, think about it. If you're standing on the beach looking out at the ocean and the sea level suddenly drops, you wouldn't actually know if it was the sea level that had dropped or if the land had risen. And when we look at the geological record going back into the past, we see changes in relative sea level, the difference between sea level and land level, but we don't immediately know which moved. So my work tries to figure out whether the sea level has moved in the past or the land level has moved. In my work, I'm kind of like a detective. I go out to the field and I collect geological data that tells us about changes in relative sea level in the past. From this, we try to decipher whether it was the land that moved or the sea level that moved. It's important for us to understand what processes are driving changes in relative sea level, because that tells us about tectonic hazards and it allows us to better forecast future sea level rise. If we can use these geological records to figure out where earthquakes have happened in the past or how sea level has changed in the past, we can use that information to better anticipate future earthquake hazards or future sea level rise. And we can work with communities in affected areas so that they can better plan to address the hazards they face and to plan for a safer and better future.